Let's talk about furnace blower motors and blower wheels. Most of your older furnaces had the standard PSC motors, and they had a run capacitor along with them. And those have kind of gone away. I mean, you'll still see them when you do maintenance work or troubleshooting on older furnaces. But most furnaces now have ECM motors. Blower motors come in a variety of different sizes and shapes and mounting configurations. They come with a variety of mounting legs. You need to make sure that whatever type of mounting you have for the blower motor, that you get it centered correctly so you eliminate the vibration and noise that can be contributed to insufficient mounting of these motors in blower housings. As we said, most of your modern furnaces now have ECM style motors with the electronics on the back end of them. And proper troubleshooting of these motors, you need to have the manufacturer's troubleshooting guides for these to know the proper voltages. One of the most common calls that we get in tech support is from a tech who says he has the high voltage to the ECM motor, but it's not running. And they have a misconception that just because it has high voltage, the motor should be running. But high voltage is supplied to the ECM motor at all times, and then there are communication lines that send the command to the motor to run. So yes, you need the high voltage to power the electronics in the back end of the motor, but you also need the communication signal from the control board to command the motor to run at whatever speed it needs for that particular mode of operation. Blower wheels come in a variety of shapes and sizes and different configurations. On most of your modern gas furnaces, you either have a single inlet or a dual inlet blower wheel. You need to make sure that these wheels are properly balanced and that they're not vibrating to cause vibration in the furnace or cause noise. And you also need to make sure that they're clean. As we've said many times before, homeowners notoriously tell you that they have changed the filter when they really don't. And when the filter gets plugged and maybe some of the dust gets past the filter and gets into the blower wheel, it can cause inefficient airflow delivery because the blower wheel is dirty. So make that a part of your routine maintenance to check the blower wheel to make sure that it's clean and it's centered properly in the blower housing and it's delivering the correct amount of CFM for that particular unit. Another consideration when installing gas furnaces is the manufacturer's recommendations for the ductwork being attached to the furnace. Many manufacturers in their installation guides have diagrams like this that show that you cannot attach ductwork to the back or to certain sides or positions of the furnace, depending on what configuration the furnace is. So make sure that you check the manufacturer's installation guide to make sure that you're connecting your ductwork correctly to the furnace. Make sure that you're aware of any notes that might be in the installation guide, such as this, that on a upflow configuration furnace, this manufacturer states that you can have any combinations of 1, 2, or 3 are permitted. So you must have either a left or right return along with the bottom of the furnace. So make sure you double check the installation instructions that you're doing it correctly. This installation instruction states that in a downflow position, the only configuration of ductwork for return air that is recommended is from the bottom of the furnace itself. You cannot have any side returns. And this instruction states that in a horizontal application, that a horizontal top return is not permitted for any model. On many furnaces, the CFM being delivered is set up by dip switches. So make sure that when you're installing a gas furnace and setting up the airflow, that you make sure that the dip switches are set correctly for the CFM that you need for your application. Make sure that you read any notes that are attached to a table, such as the one in the previous slide, that tells you that with different dip switches you can add or subtract airflow to a gas furnace. If you're installing a communicating stat on a furnace, make sure that you realize that a communication stat usually overrides any dip switches on the furnace itself. So you can set dip switches on the furnace, but any settings that you make on the dip switches will be overridden by the communicating thermostat. So all airflow adjustments have to be made through the communicating thermostat in the furnace setup. So the ECM motor on most modern gas furnaces consists of a motor body that has the windings and then a permanent magnet rotor that rotates in the middle of it. And then the motor control or the electronics are on the back end of that ECM motor. Since the introduction of ECM motors in gas furnaces, there have been very few motor failures themselves. Most of the failures on ECM motors are the electronics in the back end of the motor. But in this slide, we're showing you how to take the winding readings of the motor. You do this just like you would take ohm readings of the windings of a compressor by taking the 3 leads coming out of the motor itself and checking the ohm reading of each winding. The second check is just like taking a winding resistance to ground on a compressor. Taking a resistance reading from each of the leads to a ground will tell you whether the windings of the ECM motor are grounded or not. You should get an infinity reading, absolutely no resistance between the motor lead and the ground. As we stated previously, you will have high voltage to the ECM motor at all times, but you will not have communication to the motor unless it's calling for the motor to run. So as we said, you will need the manufacturer's troubleshooting guide for each particular model that you're working on to see what type of voltage you should read from the control board to the motor to command it to run and to stop. A note here, make sure that when you're checking these voltages, you check the voltage coming out of the board to make sure the board is outputting the correct voltage. And if you're not getting that voltage at the motor, then you probably have a problem with the plug or the wiring harness. If you want to get more information concerning ECM motors and the proper troubleshooting of those motors, a great website to go to is the dealertoolbox.com. On this website, you can download the ECM service guide, which gives you a lot of great tips on how to troubleshoot ECM motors. They also have the various testers that are available to diagnose ECM motors in the field. You can actually purchase these testers off their website. So go to the dealertoolbox.com and find all the great information that's there on ECM motors. So hopefully the tips in this video have given you some ideas of how you may go about keeping the blower wheels and motors running in gas furnaces and air handlers this winter. As we stated, you'll need the troubleshooting guide from each manufacturer, so you have all the data that you need for any fault codes and voltages for the ECM motors to properly troubleshoot the system. Also, from Carrier and Bryant, there is the application that you can put on your phone where you can download technical information like that real quick on a job site. So the information you need to properly troubleshoot a gas furnace is at your fingertips. Download the Carrier or Bryant Tech app today.
Go to Airefco.com for more videos. Like, subscribe, and check back every week for new videos.